Okay, good morning. I am Yuuki Enomoto at the Shitose Institute of Science and Technology. I would like to talk about design, implementation, and operation of NetBSD-based system packaging. It's believed that Unix operating system built on fine granular small parts is preferable to one built on the large tarballs in order to support speedy security update, easy replacement, and rollback to specific parts. In Linux distributions, the systems are already divided into many small packages. On the other hand, BSD Unix variants are behind the curve on the base system packaging. To improve NetBSD-based system granularity, we propose a framework for base system packaging. So we have developed a software-based package. This presentation shows replacement of a few OS granular parts is clearly faster and can provide extra useful function for NetBSD users. This presentation consists of these contents. Firstly, I will talk about background of our development. Historically, operating system has been managed on one source tree, and the source tree set has been distributed. In NetBSD, either of a large or small table or the combination is used. For example, basepkg and compkg and non-kgz. But third-party software not contained on the source tree. Third-party software are managed as a set of small archives called as package, where package implies a container which consists of software documentation, configuration files, and this package's metadata. Metadata required to operate in installation and deinstallation. Metadata contains build environment, comment, description, dependency, and install script. And each package role, format, and manager differs from one Unix OS to another. Historically, BSD Unix has been developed in its own source tree, including kernel generic commands, configuration files, and manuals. But Linux was released as just a kernel, so Linux distributions such as Debian and Red Hat needed to assemble a lot of system utilities. For that reason, the base system management based on a lot of small packages was inevitable and a good idea for Linux distributions. Major Linux distributions are already divided into many small packages. These OSs can manage both its own base system and third-party software through its package manager such as apt, dpackage, yum, and rk. On the other hand, BSD Unix such as FreeBSD and NetBSD have each package framework, ports, and package source. But they have been used only for third-party software management. However, today, for users, it's better that OS can be assembled on a lot of small parts, easily added or removed. It's suitable especially for rapid security update, replacement, and rollback of specific parts. Secondly, I will talk about packages in BSD Unix. As I mentioned earlier, BSD Unix consists of the base system and optional third-party software not distributed within the base system. The third-party software are called both on FreeBSD and OpenBSD. So package those on NetBSD, and we can use package those on a lot of platforms. And in FreeBSD, pkg can use to manage packaging. And metadata consists of compat manifest and manifest. In NetBSD, package install usually set of package manager can use. Metadata consists of field info, contents, disk, and others. BSD Unix has some approach for base system packaging. In FreeBSD, FreeBSD 11 introduced a base system packaging mechanism called package base. In our environment, FreeBSD base system comprises around 795 packages in the case of 164 architecture by the board. In NetBSD, NetBSD has a framework called speci introduced at January 8, 2002. It also merged into build shell as a feature of the official building process. So we can run build shell speci operation. But especially in speci, NetBSD Mix says there has been a lot of work in this area already, but it has not yet been finalized. Speci has several problems for these years. Firstly, the database and the user source distributed sets has been incomplete. Secondly, package made by speci lacks several metadata. The current package source package. Thirdly, it's possible to overwrite existing ethos files because it has not installed script. So we focused on NetBSD's package because package is suitable for powerless architectures such as N68K and PowerPG and others. And it looks like there is room for advancement, but it looks hard to directly fix this package framework, which consists of a lot of makefile, shell scripts, and undocumented data. So we have developed another packaging mechanism as a third-party software by using only speci database and making the best use of package source framework. Thirdly, I will talk about base package. We have developed a new framework, base package, that can packaging NetBSD base system instead of speci. It distributed under the 2-phase BSD license, and it published on this GitHub repository. In October 26, 2016, it published on GitHub. In May 19, 2017, it imported to package source whip. Today, the latest version is 1.4. The feature comparison between base package and speci are shown at this table. Speci consists of many makefiles and shell scripts. Base package is just a shell script up to about 1200 lines, well coded and documented, so it is easy to read. But base package slower than speci, and the base package has install script and kernel package. And we reporting progress of development on conference. And this package is optional function, but base package is third-party software. It is commonly seen that a program will be used longer than the author expected. To write a sustainable program, base package is written to be POSIX compliant and portable as good as possible. In fact, the latest code is POSIX compliant expect hostname, make them, and package create. We use shell check to validate and gain code quality and make the code running less as good as possible. The information of shell check can refer to this URL. This video shows base package processing internals. Firstly, base package is list of a set of file name and package name from mi and md.h and sets lists directories. Then, base package generates temporary files named files and plist. Secondly, base package emulates the generation of package source metadata. With supporting this metadata, build info holds information in package building, comment holds comment of package, contents holds a list of files each package contains, and command for package tools. The install is shell script which run at the installation. And this holds the description of package. Install is shell script which is run at installation. And size of holds some of size of package including dependents. Size package holds size of its package. And for essential package, preserve is contained. It indicates that this package should not be removed. Finally, base package runs package create command for all packages. In creating packages, base package gathers the package content and the deskdir directory made by build check. Then base package creates the checksum file, MD5, and SHA-512. Now, let's move on to the next part. I'd like to present usage of base package. Base package requires the latest package install, so we recommended the use of package source lib to install base package. The base package requires the built NetBSD base system. Firstly, preparing the NetBSD binary. And secondly, running base package shell with package option. On the other hand, for building kernel package, preparing the NetBSD kernel binary, then running base package shell with kernel option. About handling packages, it's easy to add or delete the specific base package by using package tools, since the package format is same as package source 1. So we can use package add and package delete for installation and deinstallation. But to avoid confliction between package source and base package packages, we should specify the other database paths such as using the GraphQL option with body base package. Currently, in using raw package tools to manipulate packages, we needed to be very careful to handle exec packages such as etc. Because it overrides files under the exec directory. To avoid this disaster, once we extract the contents in other directory and running install script. So we should prepare a wrapper for users not to handle raw package tools. We have compared the installation time between tarball extraction and using package made by base package. We processed the following tasks 100 times on NetBSD 7.1 and 64. We used the time command to measure the processing speed. 1. Fetch a tarball named games.tgz from FTP.jp NetBSD node, then extract it. 2. Install all packages beginning with games to system from base package NetBSD FML org. 3. Install one games bin package to system from base package NetBSD FML org. Where base package NetBSD FML org is an experimental base package distribution server we build and operate. Result is here. In one package installation, it's faster than tarball. But all games package installation is slower than tarball. So only when we update a few packages in the system, the process is comparable to the tarball extracting. But in almost cases under normal operation, we replace only a few small parts for rapid security update. Now, I'd like to demonstrate base package.
So base package imported to package source script, so base package can install using package source script. So base package installed to user package base package, then for package create, running base package shell with package. So in this machine, base package run requires about 5 minutes. It now running. So for if finished package is created in this directory, and these packages can operate through package out or package create. So, for example, package out large K for DB base package and transition user games is empty now. User package for the base package games binary. So user games package are installed, and if they install package delete k the base package show then package delete logic k body base package games bin. So inside games is deleted, and it can integrate it into we can use packaging for base package, but packaging it looks like packaging cannot specific to database. Okay, so is packaging. We can use packaging for these packages. So first, packaging configuration repositories file, and I edit packaging repository into this directory. So packaging will package made by basepkg can see using packaging, and packaging install games. So calculate dependency and using. So
would you type package info minus u? Package underscore info minus u. Minus u. Minus K is about
db is package. But packaging packaging the database is db package. So games bin is here. So packaging games. So games package is installed using packaging delete or delete. Remove we can remove the games package from the system. So fourthly, I will talk about discussion.
we summarize changes and improvements from last year. Firstly, we imported it to package source repository. Secondly, we updated database and sets directory. So we fix the problem. We fix the problem report number 46937 by Breadbox up to 2012. Thirdly, we enhance the following metadata: the install, press up, size package, and size all. Fourthly, we supporting cross-build. Finally, we supporting multi-platform. We have qualified basepkg shell can run on Ubuntu 17.4 and 64. But there are a lot of technical issues to resolve as follows. 1. Basepkg shell slower than build shell sys packages. We must need to try better shell coding technique. We should not use for or while loop as good as possible. Instead, use internal loops such as find and grep. 2. Basepkg database maintenance. It looks description and comments has been incomplete. 3. We should prepare a wrapper script convenient for users. For example, setting database location, setting prefix for methods package, and providing alias mapping for ambiguous package names. 4. Integrated system management support. For example, package vulnerabilities and packaging. I'd like to talk about how to use packaging for basepkg. Firstly, install package. Install packaging. Install packaging and specify repository. So and create package summary. So then package install using packaging. And we estimated all the package distribution. Package distributed server can maintain in a number of ways. In the case of building source tree and package by distribution server. In current VBS case, basepkg NetBSD FMLO, which runs on Sakura Internet VBS, 2 GB memory, 3 CPUs, and 200 GB storage. Currently, we providing 30 architectures in NetBSD 7 stable branch. One architecture requires 5 GB disk space. So the upper limit of 30 architectures are restricted by this storage limit to run build shell. We need to run a set of build shell and basepkg shell for all target architectures, since basepkg requires compiled objects. The package building process costs about 1 hour per target. If we can run process parallelly per CPU core, we need 10 hours to prepare 30 architectures. In cloud case, the evolution is underway. Cloud service is more suitable for intermittent work like this. The updates for stable branches are rare, so we don't need to build packages daily. And if we run this building process only when NetBSD security advisory is released, and the target can be distributed to stable branches modern cloud service is more proper than the current previous service. We need to estimate the cloud speed and cost, whether the cost may be lower since cloud is CPU meter rate charging. In the case of cloud service, we assume the following usage. Normally, the build process does not run. The low-cost cloud archive holds the build data. So on demand, we wake up the cloud service and extract the build data from the archive. Build packages update web service. We archive the build data and make the cloud stream again. On the other hand, in the case of building only package by distribution server, today it looks NetBSD daily build system can prepare daily binaries for some branches. Hence, base package distribution server can fetch the tarballs and build packages based on them. We hope to operate package distribution server at a low cost, but only for latest branches. Finally, I will talk about conclusion of this presentation. We have developed third-party framework based package to packaging NetBSD based system. It's shown that this framework provides more granular and faster update of NetBSD based system and useful functions for users. However, we have a lot of issues to resolve for realistic system operations. So we need to continue the coding and development. Thank you for listening. Any questions?
You mentioned problems with the NC directory. Do you plan on merging some of, like doing automatic merges of those changes, or are you just leaving it out of the user network? So with the handling the NC directory and the config files, you plan on, you mentioned installing them to a separate location. Are you going to then try to automatically merge stuff into the NC directory, or are you going to then allow the user to do it by hand? Sense?
It makes sense. If it was up to me, what I would do is use the existing tools that would set update and all the easy ones.
Yeah, we have an NC update too.
Yeah, right. That's what I use to merge the two. And just install it to a separate directory.
It's a complicated problem.
3D に待機させて、そこからコピーするんじゃなくて、マージしろって言ってますね。はい。 FreeBSD's package can merge but NetBSD's package out cannot merging. So
we borrowed the three-way merge code for package from a fossil SCM. It's BSD licensed and has three-way merge capability. So if you're interested in that, take a look at fossil.
I have one question. Why use a separate database for RDB package base or base package? Why not just use RDB package?
なんでデータベースの2つがあったのかっていう。I think it's just a migration period. Not easy to integrate. Just one starting point. 最初から混ぜちゃったらだから分けてやってるんじゃないですか。
そうです。パッケージソースは一応
できれば一緒にできればしたいけど、最初分けとこうっていうんですよね。そうじゃない。もう絶対分けない。シスパッケージだから別です。シスパッケージの別です。
パッケージソースは同じソフトウェアを使って操作をしているんですけど、コンピューターが別々のサードパーティーかベース側の、違いがあるので、今はベースがサードパーティーかで分けています。
As a nature, package source and system package may be different, so that's why he started to use a different package. Maybe it will not be merged, right? 一緒にしないですよね。Package source and base package will be different management on the database.
もし使ってるうちに、データベースが一緒の方が何かしらの都合がいいと分かったら、一緒にしますけど、今のところは。
If the thing is going to be merged or merged, maybe the beneficial he will merge, but he will continue to use a different package. The
names are very different. The format of the names are very different. Between system packages and package source. So I don't see any reason to keep them separate. The format of the names for the system packages, or base package, and for the package source packages are very different. Games, bin, or OpenSSH, 711. So it is easy to see just by looking at it whether our package is a base package or if it's one from package source. If we only have one package database, then that takes away the reason for adding a wrapper for the user to do that. Then there are a number of benefits from simplicity of only having one package database in the system, because we're not having to remember to specify it all the time wherever we go. Or if there are some things that come as a package and something that comes in as a base package, then they're in the same place. But thank you, this looks great. It really does look great.
Thank you.
聞いてみます。いいんじゃないでしょうか。あ、これがどこに日本人の方、もし僕がいるときにはマイクのとかにありますけど、もしいないときとかは僕部屋移動するんで、
適当にやります。こっち入れば。いや、今日耳配布されなかったんで、見ちゃいます。いつも配布されると思う。